Welcome back to Money and Banking. Continuing on with Chapter 14. This is Part 2 of Chapter 14. In Part 1, we looked at the balance sheet of the Fed, the non banking public, and the banking sector. And we saw how central bank actions in the form of open market operations and or discount loans could impact the monetary base. Now we want to understand the process of money creation, which is a proliferation of the monetary base through the process of making loans, essentially, in the banking sector. And we'll try to figure out how much overarching purchasing power or money supply can be supported with a given monetary base, if you will. Let's just start with the phenomenon of deposit creation, and here we're looking at an individual bank. This bank is going to go through basically two stages that are designed to kind of highlight how a checkable deposit is created, right? In the first panel, off into the left, what we see is there's been an open market operation, in fact, an open market purchase, the Federal Reserve of this bank. And so the Federal Reserve purchased a security from this bank, and the bank lost one of its assets to the tune of $100. And the bank was compensated for this open market purchase with a liability on the Federal Reserve. And that liability on the Federal Reserve is counting in the asset column of our First National Bank. They now have $100 in reserves here, right? Now, the general idea here is that the bank's not going to be making really any profit off of this transaction because the reserves are just sort of sitting at the central bank. Now, it is true that the central bank can choose to pay interest on reserves, and so some small amount of money would be trickling into the bank, but that's not what banks do, right? Their job is to loan and make profit off of those loans. And so in the second panel, what we've gone ahead and assumed is that First National Bank has taken all of its reserves and converted them into loans. And so First National Bank has made a $100 loan that goes out into the economy, gets used to purchase something, and then whoever sold the thing ends up depositing their revenue, the check, in the bank. And so we're just assuming a one bank economy here. And so now there's $100 worth of checkable deposits in the system, $100 of checkable deposits in First National Bank here. And so the central bank's balance sheet balances out, First National Bank's balance sheet balances out, the entire system is solvent. And what we've seen happen is that what was once reserves now becomes spendable cash. It becomes money. And if you remember from our definition of money, particularly M1, right, narrow money, it included very liquid forms of assets. Certainly currency was in that category, but so too were things like checkable deposits. And so what we've seen here is an increase in the monetary base that has consequently increased the money supply. There's now an extra $100 of checkable deposits, right? But it makes no sense for the bank to loan out its entire reserves. I mean, if you think about it, right, they've created a loan of $100. This has become a deposit of $100. Somebody now has a liability on the bank. It's their asset. It's the bank's liability. It's to the tune of $100, and they can come in tomorrow and ask for $5 or $10 or $15 or $100 if they'd like to, right? So the issue here is that the bank has to remain not only solvent, which is that their assets match their liabilities. They've got a loan for $100 and a liability on a checkable deposit of $100. But the bank also has to remain liquid, if you will, right? So if it is the case that the person who now holds the checkable deposit of $100 normally just comes in and takes out $1 a day in order to buy, say, a cup of coffee or something, then the bank, well, it's solvent because assets match liabilities, but is it liquid? Well, the bank is liquid if it can meet these withdrawal requests. So the individual comes in about every day, gets $1 for coffee. In order to remain liquid, the bank then can say, well, we have to make sure that the payments of principal and interest on this loan, the payments into the bank, are matched with the withdrawals from the bank. And so the terms of the loan that they set up say, well, in terms of principal and interest, you owe me $1 a day, and then the individual withdraws $1 a day to buy to buy coffee, if you will. Now the bank is solvent, assets match liabilities, and it's liquid. It's able to meet its withdrawals. It's able to meet its liquidity withdrawals, right? So assuming that you can predict liquidity withdrawal perfectly, you could set up your loan portfolio to pay in money as it was going out, right? But there's obviously going to be variability in withdrawal, and it will be impossible to predict it perfectly. And as a consequence of this, the bank it's running the risk of being solvent, assets match liabilities, but potentially illiquid, right? Suppose the individual says, well, I'm going to take my friend to coffee today, and I need $2 from the bank. The bank doesn't have it. They're illiquid. So in order to guard against this risk that you might face liquidity crunch, right, it is oftentimes required of the banking system, and it certainly is in the United States, to hold a specific amount of reserves idle as vault cash, right? And this proportion of deposits that must be held as idle banking reserves, they can't be loaned out, they just have to sit there in the vault, and they can be used to handle jumps in liquidity withdrawal. Well, there's a proportion of those deposits that must be held idle. It's like a buffer zone, if you will. And in this example, we've taken a reserve requirement of 10%, right? So 10% is the amount of deposits that the bank cannot lend out in order to try to make money on. They have to keep it in the vault idle. And this allows them to meet changes in liquidity withdrawal or unpredictable changes in liquidity withdrawal. So now with this idea of reserve requirements, let's go ahead and think about how this process of deposit creation takes place. So we have Bank A, right? And Bank A has gone ahead and there's been an open market purchase, right? Their securities have gone down by 100, their reserves have gone up by 100, and then the bank says we need to make money off of these reserves. And so they want to lend them out. But the requirement is that they can't lend out the full $100. They have to hold 10% idle as vault cash. And so this is what they've done in the second panel to the right for Bank A. Their reserves are now $10. Their loans are $90. So this reserve requirement of 10% means that 10% has to be held idle and the other 90% can be loaned out. So the bank makes a loan not of $100, but makes a loan of $90, right? Very, very good. That loan of $90 gets taken out by a business person or a consumer, and they go and they buy something with the $90, and whoever they bought the thing from takes their revenue and they deposit it in their bank. That's Bank B, right? Now there's been a $90 increase in checkable deposits, and there are $90 in reserves. Bank B has to keep 10% of this deposit idle in reserves, so it's going to take $9 and keep it in reserves, and then it's going to loan out the other $81. And Bank C, right, is going to see a deposit of $81, and 10% of that's going to be held in reserves, and the rest is going to be loaned out, right? So what we're seeing here is a growth in the money supply, right? Let's see if we can look at this growth of the money, right? Our first increase in deposits was $100, and then all of a sudden there was $90 of that loaned out. Yeah, $10 was the amount kept in Bank A, and that was, of course, an accumulation of our reserves. Bank B then saw an increase in deposits of $90. It was able to loan out 90% of that, $81, and kept 10% of that in bank reserves, $9, right? That $81 got spent in the economy, became an income for someone, and was deposited in a bank. 10% of that was weaned out and held in reserves, so 8.10. And then Bank C here was able to make a loan of $72.90. And the process continues over and over and over again, right? So the general idea here is that any given change in the monetary base, like you purchase a security from a bank for $100 and now the monetary base is increased by $100, well, that's not the end of the story because, right, each injection into the banking system gets recreated in the form of a loan. However, those loans become increasingly small because a portion of every deposit must be held inactive, must be held idle, right? So every time we cut this replication down by 10% and we see deposits increase, although the increase in deposits is getting smaller each time, there's a deposit and a loan created, a deposit and a loan created, right? And our reserves are starting to actually accumulate within the system, right? Because every time there is a transaction of deposit and loan, a certain proportion of it, the required reserve proportion, gets weaned off and held in reserves. So what we saw here was a $100 increase in the monetary base, but the increase in deposits is some multiple of that, right? And the multiple depends upon the size of the required reserve ratio, right? The larger the reserve ratio, the smaller subsequent loans will be, and the more quickly this process of increasing deposits through making loans will, trickle out to nothing. The smaller the required reserve ratio, the larger the subsequent round of loans and deposits that will be made, the more of them that will be made, and the longer this process will be able to continue before it trickles off into nothing. Now, keep in mind here that what we saw initially was a purchase of security for $100. There was a $100 increase in the monetary base and an increase in terms of liabilities on the Fed of $100 as well, right? If we look at the first column, this is our increase in M1. This is our increase in the money supply, right? Because these are all deposits, right? Not currency, but deposits. And if we were to follow this whole iteration over and over and over again to banks C, D, E, F, G, H, I, G, so on and so on and so forth, and we totaled up all of the deposits that were created by the initial open market operation, these would all total out to be 1,000, right? So we saw a $100 change in the monetary base, and that led to $1,000 of new money, or an increase in the money supply of $1,000, right? Now, of course, this increase in deposits is equal to the increase in loans that were made, because each loan became a subsequent deposit and so on and so forth. So it makes sense that the total for all the banks in the system in terms of loans would be the same as that of deposits, which is $1,000, right? What's interesting to note is that if we look at the accumulation of reserves in the banking system, first it starts off at 10 and then 9 and then 8.10, 7.29, and every time a loan is made, right, there's another deposit that's being accumulated in the form of reserves, right? And if we total up all of the reserves in the system at the end of the money proliferation process, we see that there's an increase in reserves of $100. And remember, those are kept at the Fed, right? Or even if they're kept in the vault cash, they're counted as being kept at the Fed. So we saw an increase in liability in the central bank of $100, and now we see an increase in assets as well, right? So the Federal Reserve balance sheet is balancing out, and we've seen $1,000 worth of money creation out of a single $100 increase in the monetary base. And do keep in mind, since the effect of an open market operation or a discount loan are identical on the monetary base, we could have run this same story by motivating it by a $100 increase in discount loans rather than a $100 purchase of a security from the banking system. It wouldn't matter either way. Both of those mechanisms impact the monetary base, and both of those mechanisms set off this sort of multiplication process or proliferation process of money creation. That concept that we've just seen can be boiled down into a handy little formula, right? We're going to be assuming that banks really don't try to hold any reserves in excess of what they're required to hold. And that's a certain assumption. It says, well, banks are going to take advantage of their deposits as much as they legally can. And the reason that might motivate that is to say, well, banks want to make money. They want to make profit off of the interest on their loans. So, why would they keep money that could be made profitable by making it into a loan? Why would they keep that idle in reserves, right? So in the simple case, we'll assume that banks just have no motivation to hold excess reserves, and so they're going to use as much firepower as they can. Now, keep in mind, in reality, banks will be concerned about the amount of risk that's in the economy and how risky the borrowers are and how likely those loans are to be paid back. And so in an environment in which there seems to be economy-wide risk that's growing, a bank might indeed find it optimal to curtail their loaning activities until a less risky time. And in this scenario, you'd see the bank accumulating these excess reserves, reserves above and beyond what they were required to hold. I think you all can kind of recognize that if the bank's not loaning money because it's accumulating excess reserves, that the process of money creation is stunted by that. And so we'll look at the role of holding excess reserves, as well as the role of banks perceiving a lot of risk in the economy, and we'll look at the impact of that on the money supply, the overarching money supply. We'll look at it later on. And the same qualification we'll have to discuss in terms of currency, right? Because if individuals are holding money in currency rather than depositing it in the bank, then that money can't go through this multiplicative process. So, in this simple model of deposit creation, we're kind of, in fact, we indeed are assuming that excess reserves are zero and that the public has absolutely no preference for holding any currency whatsoever. It all goes into a deposit in the banking system. So we've got our required reserves, we'll call those RR, and these are going to be equal to total reserves, R, in the system. RR is required RR, or our required reserve ratio, little r, times the amount of checkable deposits, D. So we also saw that if we looked at the total amount of deposits, you'll notice from the last slide, overall we had $1,000 worth of deposits. And if we take the required reserve ratio and find out what fraction of those deposits were held as reserves by requirement, then of course we get R, right? The total amount of reserves in the system. So there's a couple different ways you can solve for the amount of reserves in the system. Probably the easiest one is to take this identity that says, there's a certain amount of deposits in the system. How much is held as reserves? Well, once we know the required reserve ratio, we have that. And in our case, of course, there was $1,000 of deposits, D. There was a 10% required reserve ratio, little r. And so consequently, there was $100 worth of reserves accumulated in the overall system. We saw that in the last slide. If we go through and we divide both sides by r, then what we've done is we've kind of motivated an equation for solving for how many deposits are in the system, right? So if we have $100 worth of reserves in the system, this has been a change in our monetary base because reserves are created by changes in the monetary base. We then multiply that by 1 over r. In this case, that's 1 over 0.10, and that gives us the amount of deposits that can be supported for a given monetary base, right? This equation tells us the amount of deposits that can be created from a given level of reserves in the system. If we want to start thinking about change, right, how much will deposits grow for a given increase in reserves or a given increase in the monetary base, then we can take a difference equation of this. And our last equation on this page is exactly that. Delta, of course, means change. And so the change in deposits that would come from a given change in reserves is equal to delta R multiplied by 1 over the required reserve ratio. In our case, previously, we saw reserves increase by 100, and we multiply that by 1 over 0.10, which is 10, and it gives us $1,000 change in deposits. So this idea for this multiple deposit creation formula forms the intuitive root of the overarching process of how the money supply, D, is impacted by changes in the monetary base and Federal Reserve actions that impact it, R here. Now, this is a simple sort of intuition, and it's supposed to give you kind of the mechanics and the logic behind what's happening. By the end of this lecture, we'll actually develop a money multiplier that takes into account all of the other factors that might be at play in the money creation process, such as whether or not banks are holding excess reserves and whether or not the public has any sort of preference for holding a portion of their deposits in currency rather than in banking deposits. But if you understand this, the last two slides in essence, then you really do understand the overarching process of the money supply creation process, and you're certainly ready to fine-tune that understanding, as we will do so in a moment. But we can simply just look at a simple example of this, a question that you might be sort of given at this money and banking level in a homework or an exam or something else. Is suppose the Federal Reserve undertakes a purchase of $3,000 of securities from the banking system. And so you've seen the monetary base increase by 3,000. You've seen reserves in the banking system increase by 3,000. Now, loans are going to be made and deposits are going to be created. And rather than go through the entire iteration, let's go ahead and use our knowledge to solve for what the overall change in deposits will be. And so once we know the required reserve ratio, again, we'll assume it's 10%, we can use the equation on the previous page for the simple multiple deposit creation formula, and we can solve for the delta D, right? What will be the change in deposits from this new change in reserves of $3,000? So it's simply 3,000 multiplied by 1 over the required reserve ratio, and we see deposits increase by the tune of $30,000, right? Fantastic, right? Now we could back solve that as well, right? If we had $30,000 of new deposits created and 10% of them were weaned off and held in the form of reserves, of course we'd have $3,000 worth of reserves. So we can work this equation to answer whatever question we want, depending on what information we have, trying to solve for what information we don't have, right? Now, let's look a little bit about what happens when the reserve ratio changes. In the next little equation, what we've assumed is that the reserve requirement has declined. It's gone from 10% and it's declined to 5%. So now every time there is a deposit, a larger amount of money can be loaned out again, and it will take more rounds of loans and deposits for that to be whittled down into nothing. So as we've gone ahead and changed the required reserve ratio to 5%, we now have this multiple deposit formula being adjusted by having 1 over 0.05 rather than 1 over 0.10. And that effectively increases the money multiplier, the multiplier for deposit creation. And now we're seeing that $3,000 change in reserves get cycled through the system for a longer period of time, and this leads to an increase in deposits of $60,000. So here the lesson is, right? One, know how to apply the formula, and two, right, one of the ways that you can control how large the increase in the money supply is by determining the required reserve ratio. If the central bank sets a high required reserve ratio, there will be a smaller proliferation of money than if the central bank sets a low required reserve ratio. And of course, there will be a higher proliferation of deposits. And so your required reserve ratio is, right, inversely related to the size of deposits that can be created from this type of banking. Incidentally, this type of banking is pretty much the same the world over, and it's known as fractional reserve banking. And what you'll have noticed from our dealing with the balance sheets is that fractional reserve banking leaves the entire system solvent, from the central bank all the way through all the banks that are participating. And unless there's some crazy change in liquidity withdrawal preferences, the entire system should be solvent as well. We'll look at some historical cases where the latter statement is not true, and we've seen some of these banking crises more frequently in the far past, but actually some pretty close runs-in with them more recently. And we'll talk about why that is, right? When you see a massive spike of liquidity withdrawal that exhausts reserves and causes banks to be illiquid. We'll discuss that when we talk about the Great Depression in a second. Okay, we've had our simple model, and in that simple model, of course, we made some assumptions. We mentioned those assumptions to you, right? Well, one of the issues is that banks can't make loans out of deposits they don't have. And so if individuals are holding money as cash rather than as deposits in a banking system, that cash can't be loaned out and the replication process cannot be allowed to continue. So holding cash stops the process, right? A currency has no multiple deposit expansion. Banks, on the other hand, may not use all of their reserves to buy securities or to make loans, and so they may hold excess reserves above and beyond the required reserves, right? And if they're holding excess reserves, of course, they're not making loans, and the process of expansion is halted there as well, or stunted there as well, right? So overall, we've got two factors that can reduce the impact on the money supply from the simple model that we just looked at. And one of them is, hey, how much cash do people wish to carry? And also, what are the decisions among the banks in terms of holding excess reserves? Understanding those concepts now, we kind of have all of the basics that we need, and this table summarizes what we've learned so far, right? So the Federal Reserve could perhaps change the non-borrowed monetary base or the borrowed monetary base, either by conducting open market operations or making discount loans. If they were to increase either the borrowed or the non-borrowed monetary base, then of course this multiple deposit creation would kick off and we'd see an increase in the money supply, right? If they were to increase the reserve requirement, this would reduce the rounds that were taking place with this expansion, and that would reduce the money supply. Depositors, on the other hand, if they decide to hold currency and hold more currency, if that variable were to go up, this would reduce the money supply. And banks, if they choose to not make as many loans, holding more excess reserves, right? If they increase their excess reserves, then of course the money supply will fall for that reason as well. And so this is a nice summary chart to give you kind of all the simple ups and downs and tools and variables that are important to determining the expansion and contraction of the money supply, both dependent upon the Fed, which of course include required reserve ratios, borrowed and non-borrowed reserves, and their impact on the monetary base, and things that affect the money supply that are independent of the Fed, such as currency holdings of depositors, as well as excess reserves in the banking system. Factors that determine the money supply. Well, changes in the non-borrowed monetary base. The money supply is positively related to these, right? Changes in the borrowed reserves from the Fed. The money supply is positively related to these as well, right? These are the tools of the Fed to try to impact supply. Changes in the required reserve ratio can also impact the money supply. Changes in currency holdings can impact the money supply. And changes in excess reserves can impact the money supply. I think we feel comfortable with all of this. So now that we've got all of the factors that we need in order to analyze the money supply, let's try to put them all together and move from our simple formula for deposit creation to a more articulated, nuanced formula for impact on the money supply at large. So we're going to define M as being the money supply, and our M is going to be M1. So it's going to be narrow money. So think of M as M1, our narrow money, right? Currency checkable deposits, traveler's checks, and so on and so forth, right? We've now able to link the money supply to the monetary base, which was the borrowed and non-borrowed reserves in the system, open market operations, and discount loan capabilities. And now we know that there's going to be some proliferation of changes in the monetary base that creates overarching money, and we'll call that factor M, and M we will call the money multiplier. The money multiplier has to be more nuanced and articulated than the required reserve ratio that we looked at in our simple formula. So let's go ahead and take into account all the other elements that are going to impact this, right? So we're going to need to look at, well, how much of each deposit does the public want to hold as currency? This will be our currency ratio, right? The fraction of every deposit that individuals withhold as currency rather than make a deposit. And so little c will be that proportion. It's the little c is the currency ratio. It's the proportion of deposits that's held in currency. And this is up to the public's preference, if they will. And you might be thinking now about how different economic events would cause people to maybe be more trusting in the banking system and have lower currency ratios, or be less trusting in the banking system and have higher currency ratios, right? So these factors in the economy will impact the money supply through changing the money multiplier. We also want to have a feel for, what is the cautiousness among banks. So what we have here is the excess reserve ratio, little e, and it is the amount of excess reserves out of every deposit. So how much of every deposit is held as excess reserves. So now we know the amount of deposits that are held idle in vault cash. It's the required reserve ratio. We know the amount of deposits that are held as excess reserves, it's the excess reserve ratio, and we've got amount of the deposits that never make it into the banking system because they're held as currency. That is our currency ratio. We can now factor these all in to our proliferation process. The total amount of reserves, R, is going to be equal to the sum of the required reserves and also any other reserves that the bank chooses to hold. And so let R be equal to exactly this, the required reserves and the excess reserves. Another way of defining required reserves, as we saw, was to look at the amount of deposits and say, well, how much are they required to keep? This is determined by the required reserve ratio. And so RR, required reserves, can easily be solved for by knowing the required reserve ratio as well as the amount of deposits in the system. If we go ahead and use these two equations, we can substitute for RR, the required reserves, in the first equation. And what we see is that total reserves in the system will be equal to little r multiplied by D, again, that's required reserves, plus excess reserves. We have ER there. The monetary base equals the currency plus reserves in the system. These could be either borrowed or non-borrowed reserves. And so we want to be able to make sure we've accounted for the entire monetary base. This will include required reserves, which will be little r multiplied by D, excess reserves, ER, and of course the amount of currency, or C. Final step in calculating the multiplier is to just kind of make some simple substitutions, right? And so let's go ahead and do that now. We have our currency ratio, and it is the amount of deposits held as currency. Another way of looking at this is that C, the amount of currency held, is equal to some proportion, little c, of deposits. That little proportion, little c, again, gives you the percentage of deposits that are held as currency. You looked at the same structure of a formula when you were trying to solve for the amount of required reserves, right? You needed the required reserve ratio and the amount of the deposits. Here, we're solving for the amount of currency in the system, and it is the currency ratio, little c, multiplied by deposits. Our next line basically goes through the same exercise for excess reserves. We have our excess reserves, ER, equal to the excess reserve ratio multiplied by our deposits. And now we can substitute these into our equation for the monetary base to get the equation on the fourth line here. The monetary base is equal to R multiplied by D, so that's required reserves, E multiplied by D, that's excess reserves, and little c multiplied by D, well, that's currency. So our monetary base is set forth there. We simplify this by factoring out the D, and what we have for the monetary base is little r little e plus little c multiplied by D, the amount of total deposits in the system. Now, we want to relate the monetary base to the amount of money supply, right? Relate it to the amount of deposits that are going to be created, and then also include currency. And so let's go ahead and solve for D. And doing so, we're going to divide both sides by R plus little e plus C, right? What we get is the deposits in the system are equal to 1 over the summation of the required reserve ratio, excess reserve ratio, and currency ratio multiplied by the monetary base. We're almost there. Our next step is to note, of course, that the money supply includes not only deposits in the system, but also currency in the system, right? So M is going to be equal to deposits plus currency, and we now have a nice little substitution that we've used for finding the amount of currency in the system. It's the currency ratio multiplied by deposits. We can then, of course, factor out D again, right? And we have M is equal to 1 plus the currency ratio multiplied by the amount of deposits. Making one further substitution, right, allows us to make it to the next step, which is that the overarching amount of money in the economy is the money multiplier multiplied by the monetary base. Our money multiplier now has taken into account currency preferences, the required reserve ratio, and also the excess reserve ratio. So we've just solved for little m, the money multiplier there. And that is our articulated money multiplier. It has the same function as our simple, expansion formula, but it includes or is calibrated for changes in currency preferences as well as changes in the excess reserve ratio. Let's throw some numbers at this and just look at how it flushes. Supposing you had a required reserve ratio of 10%, the currency in circulation was 400 billion, checkable deposits were 800 billion, the excess reserve ratio was 0.8. Oh, excess reserves are actually 0.8 billion. That's not the reserve ratio, that is the total amount of excess reserves in the system. But we can solve for the currency ratio as well as the excess reserve ratio. The money supply is C plus D, and that comes to 1.2 trillion. Let's go ahead and solve for the currency ratio. We've got the amount of currency held in the economy is 400 billion. The amount of deposits is 800 billion. So the currency ratio is 0.5, right? 50% of these deposits are held in the form of currency. That's a huge currency ratio. The excess reserve ratio is 0.8 billion. And of course, we've got deposits of 800 billion. And so the excess reserve ratio is given to you there at 0.1%. We can now use these because we've got little r, the required reserve ratio, the currency ratio, and the excess reserve ratio to calculate the money multiplier since we've already solved for it. And flushing out the math on that, of course, we see that the money multiplier is 2.5. Now, you might keep in mind that if this were simply a model of a very simple deposit creation with zero currency preference and zero excess reserves, then, of course, the money multiplier would be 10, right? 1 over 0.10. But these factors that reduce the impact or the size or the power of the money multiplier are certainly in play here, notably very large currency holdings among the public, and that's reduced our money multiplier from 10 down to 2.5. I want to stop this lecture at this point, give you guys a chance to go and review this sort of short lecture if there was something that you maybe missed or you want to go over again or listen to again. I highly recommend doing that if there was any gaps along the way. And then we're going to come back with a part 3 of the money supply process. I'll try to keep it also as a relatively short lecture. And what we're going to do there is we're going to take our understanding of this nuanced money multiplier and apply it to a historical episode of crises, namely the bank panics that occurred as part of the Great Depression. All right, so we'll move on to that next.